Kiki. Hey, Christina. Good to see you guys. It's good to see everybody too. I think, yeah, you guys can hear me. Yeah, we have a lot of stuff that I want to look at. Oh, so we're looking at transformations tonight. This should be the last one we're doing. Um, I will focusing mainly on transformations. You know, so it's good to see you guys. Even though it's a Friday, you know what I mean. Everybody loves them Friday, but still, let's see what we can do. Kiki, you say you need help especially in transformation matrices. Oh, I wish we had the time to do that one, because today we're focusing on just transformations. But I'll see how I can help you here, and then yeah, we'll see what happens after that. Night as well, Jason. No problem, Kiki. I'm happy that I can help. Yeah, Christina, let's see. Let's see. But I know students will definitely be binging between now and Wednesday. Exam is the first. So I mean, everybody ready. Everybody trying to get ready for the exam. So they're gonna be here. Everybody's gonna be here, and I hope what we're doing here, of course, helps. All right. So today we're working on transformations. Let me see if I can just hurry up log in my phone. Today we're working on transformations, Zine, and we're gonna be focusing mainly on the stuff that are put in the poll. So if you look at the poll, you realize I asked you which area you need help with. I realize, let me look at the results now. Most people are saying, well, it's kind of even between translation, rotation, and enlargement. So I guess that's everything, right? No problem. We'll see what we can do for today. Let me just bring it up on my team so I can see what you guys are saying. Guys, let's find that again. Let's see this. All right, boom. So let's see what we can do. And the first thing I want to start with, which kind of builds on the question that I had asked, is what do you know about transformations? Those are some of the stuff that we want to look at first, because we have to start somewhere, don't it? Once we can start somewhere, then we can build. Yeah, I'm gonna end the poll now. I think it's kind of at the top. Yeah. So let's start there. Kind of going to try and get an idea of what you guys know. From there we can build. From what I'm seeing, a lot of people are saying they need help with transformation. So I'm not going to ask you to rate yourself on a scale of 1 to 10. Probably the main thing I need to do is let's start with the first one. So when we talk transformations, we're talking about geometry, right? And we're just talking about how objects change. Now, a transformation refers to either a change in the size, location, or shape of an object. So once you remember those main things, those three main areas, then you can classify and you should be able to identify your transformations. Alright? So we know that we have translations, okay, and a translation just moves an object. So it would be like sliding. It's another word for it is to slide, okay. And in translations, we know what are some of the things we have. We know that we have what they call the translation vector. Let me know in the chat. Anybody remember what that is? The translation vector in a transformation? Let me see what you guys are thinking. Who remembers that? Translation vector. So let me look in the chat now, see if anybody remembers what that is. Remember what it means and what it has to do with? Or not really? It's like, kind of remember, but that's 100. What say you? Oh, you kind of know the formula in a sense, but not really what it is or what it means. All right, let's talk a little bit about it. So because a translation tells us where a figure moves, the translation vector tells us how much it moves across. So that's either left or right, and either up or down. Okay. So a translation vector is usually written in this form: x, y. So the number at the top tells you how much it moves in the x direction, and the number at the bottom tells you how much it moves in the y direction. So for example, if I had a translation vector of 3, 4, that means it moves 3 units. For the number at the top tells us how much it moves to the left or the right. To the right is positive, so 3 units to the right, and 4 units up. So basically, if we have something, this translation vector is going to move it 3 units to the right and 4 units up, something like that. If I had a translation vector like -1, 2, see, -1, 2, what do you think that means? What would you say that means? So write that one in the chat for me. What does a translation vector of -1, 2 mean? What do you guys say? All right. Yeah, that's right. To the left. To the left, to the left. To the left. That's right. So it means to the left on the... A negative means to the left. So it's 1 unit to the left. Because remember, this tells us the x direction. And what does the 2 mean? Now remember, down at the bottom, it tells us the y-axis. So a positive would be up and a negative would be down. So because it's 2 units and it's positive at the bottom, it means 2 units up. Alright? Alright, so that's the main thing that you have to remember with translation. Key is a translation vector. Now, another area that we want to know when it comes to transformations is reflections. Okay? And reflection is, when we talk about reflections, based on what I see here, the least person said that they needed help with reflection. So I would imagine that we kind of know what it means. But it just means to flip something in a line. So when we talk about reflection, some of the key things we think about is the mirror line. Right? And when you think about the mirror line, that's the line that you flip it into. You flip the figure into. Okay? So one of the main things that we have to know when it comes to the mirror line, we have to know how to write the equations of lines. That's pretty important. And we also have to be aware of the distance between them, because the distance from the mirror line is the same for both the image and the object in a reflection. Okay? So let me check if you guys know how to identify those lines. What if I had let me draw up a little axis here just to make sure. So I draw up a little axis and I'm gonna put a vertical line on my graph. I'm not gonna say what it is. But based on where my line is, what do you think the equation of that line could be? So what could the equation of that line be? Because you have to be able to get the equation for your mirror line before you do anything else. So what say you? Just write it in the chat. What do you think it could be? Let me see if you guys are familiar with it, or if we need to just touch it a little. Yeah, let's see what you think. Alright, looking out for some. See two. I'm looking for about two more. So just give me an estimate. What do you think it could be? Alright, so I'm seeing some. Now let's talk about it. So some people are thinking x equal 2, x equal 3, and yeah, because any line like this is in the form x equals something. Okay, so that's when we talk about vertical lines, that's what I mean. So it could be x equal 2, or it could be x equals 3. Could be x equals 10, it depending on the size of the scale. So it could be any one of those. The reason why it couldn't be x equal y though, or y equals x, is because that line is a line that looks a little bit something like this, and it runs straight through the origin. So that would be the line y equal x. So that would be a different thing. So you see, anytime now we have a line that's in the form y equals mx plus c, where m is a value that is not 0 or something, then it's going to be a line like that. But otherwise, that would be the line y equals x. So yeah, that could be possible value. So this line is the equation x equals something. And one thing that can help you, look at where it cut, which axis it cuts and where. Right? So it cuts the x-axis at a value. So that would be x equals k. And likewise now, let me put this green line here. Oop, that's definitely not a line. This line would on the contrary be y equals some constant value. Okay? So it could be y equals 2, y equals 3, or whatever. See? So that's one of the main things that we have to remember when it comes to the mirror line, because we can plot it anywhere. And then as we say, it reflects one object into the other. Now, the two other transformations we want to look at is, the third one is the rotation. Okay? Okay, you see what I'm talking about now, Kiki. Good. So the third one we want to look at is the rotation. Right? And when we talk about a rotation, another word for it is to spin. So it just means that we turn something in the or about a point. The good thing with CXC is that they only focus on rotations about the origin. Yeah. So once you're familiar with those, then you should be okay. But you have to be familiar with them. That's the key. Right? So when we talk about rotation, some of the key things to remember is that the direction can either be clockwise or anti-clockwise. It has to have a center. And as we say, for CXC only deals with the origin. So they only rotate things about the origin. And we have to have a degree of rotation when we talk about it. Cool? Now again, CXC only focuses on 90, 180, and well, 270 and 360. But you know 360 is a full circle. So they only focus on these quarter turns. It's 91, 82, 70, right? So once you know those, once you know what happens in those, then you should be fine. The funny thing though, you know what I noticed? I was looking through some papers recently. They only, not to say that they're going to do it this time, but they kind of mainly focus on just describing rotations. I notice they don't really ask you to do them much. I don't know. That's just what I observe. So I think once you know how to identify, 'cause you can kind of look on the paper and know, then you'll be able to tell whatever the rotation is. But nevertheless, we still can look at there are some things that happen to the points when we rotate, some general observations, and now these would be good to know as well. And let me draw up a little axis here and put up figure. So let's call this, put a little triangle here. So I'll put a point. Triangle probably too much. So let's say we have a point here with mainly, let's call it a XY point. If I were to rotate this point 90 degrees, anti-clockwise, because remember clockwise means the hands of a clock. So when you think about clockwise or anti-clockwise, just think about a clock. See, that's an alarm clock, look, something like that. That look more like a Pokemon, I don't know. But clockwise mean it's going in the direction that the clock is going. Anti-clockwise going against it. So this would be anti-clockwise. Anti-clockwise. See? Now, one thing that you can kind of use to help you remember is that for XY, notice that if you kind of spin it over to this direction, what you notice happen to the X and Y values. In a rotation, once it's 90 degrees in either direction, the points will swap. So that's an observation. Is anybody familiar with that one? You know what happened to the points in that case? Let me know. Do you know what happened to the points in a rotation? So let me just check. You know, I should have probably put that as like a poll or something. but do we know what happens? Do we know what happens? Yeah, they swap. Good. They swap. All right. Okay, you guys know. Good. That's good. So now remember, this can kind of help you to think about it. So once it's a 90-degree rotation about the origin, the points are going to swap, whether anti-clockwise or clockwise. But if it's anti-clockwise, if you kind of do a little sketch of the graph, it can help you to remember which points change. Or the signs of which points change. So let me call this AB instead. The points are going to swap, so it's going to be BA, but look at what happens. It goes from a positive X over here, on the positive quadrant, over to the negative one. So we know then that it is the negative one that is going to change the sign. Sorry. The X value is going to change the sign. Alright? So the points swap and the signs change once it's a 90-degree rotation. Okay? Now, if it's a 180 degrees, so let me write 90 here. 90 degrees here. If it's a 180, they stay the same, but the signs change. So that's one thing that you can remember. I'm seeing Kitty say, I don't know what happens, but I don't understand how to write it. When you say how to write it, like what you mean? When you say how to write it, what you mean? Let me see if I can pick up and let me see if I can help you with that before we actually do some. So the swap here, the exchanges, if it's one, it will rotate it another 90. It's gone to 180. So I'll write in the meanwhile until you can tell me. So now goes back to AB, but now they're negative. Alright, and then it gone again now over here. So as we say, they swap, but they swap, but now the Y is the one that's going to be negative. So it's going to be BA, but it's B negative A. Okay, so you know what can help you? See if you remember one of them for the 90 degrees, just stick to one and it can tell you what the other one going to be. And then for 180, just remember that their signs change. Alright? So for example, if I were to say, if I wanted it to rotate 2, 3, 90 degrees anti-clockwise, what would that be? So let's say we have the point P, 2, 3. I want to rotate it 90 degrees anti-clockwise. What would that mean? What would it be equal to? Let me see what you guys are saying in the chat. Oh, you mean how to plot them? You mean like where to write the X and where to write the Y? That's what you're saying? That's what you're saying, Geeky? I just want to make sure. Hey, butterfly girl. It's good to see you. So is that where you're talking? I'll give you some time to let me know. Can write. In the meanwhile, yes, that is right. What's the bush? 90 degrees anti-clockwise. Well, no, it's supposed to swap, you know. It's supposed to swap. It's supposed to swap. So that is not negative 2, 3. It's actually 3, negative 2. Because remember, they swap and then the signs change. Right? Oh, you're saying to do the points. One thing you can remember when you're plotting points, you plot the X first and then the Y. So you can kind of remember it like an alphabet. In your alphabet, X come before Y. So you can do that for sure. Alright? So yes, it would be 3, negative 2 is 90 degrees anti-clockwise. Let me give you one more just to make sure. What if I wanted it 180 or no, 90 degrees clockwise? What would that be equal to? So think about it now. 90 degrees clockwise. Remember now, they have to swap. But then where does it go? Draw up your little graph here. So it goes from 2, 3 and you rotate it 90 degrees. So it's going to go in this direction. What is changing? Which one of them is changing? Okay? Look at it. Which one is changing? It going from the positive Y down to the negative Y. So you know so then going swap, but now you know is the Y is the one that is going to change. That's the way I try to remember it. I hope that helps. You use which one you prefer, but that kind of helps to make sense in where it is turning. You get what I'm saying? So drawing your little sketch can help. Right, Kiki? Drawing your little sketch can help. So, you know, say, you can turn it on your little sketch and then you can know which one of them change for the 90. And then you just remember, say, the 180 stay the same, but the signs change. Alright? That making sense, guys? Let me know if that helps. Let me know if that helps. Alright, let me look in the chat. Yes, good night, Jonathan. Butterburger, LOL. Kiki, yes, the Y value is what would change for that 90 degree clockwise rotation. Alright? Last one. Just to make sure so we're good with it, you know. Let me just make sure. What here do look like we're going to do no question tonight? Last one. What if I had a point? What if I wanted to rotate the point A, which is negative 5, 4, 90 degrees anti-clockwise? So now, again, with the help of my little sketch, draw a little sketch. I will now say negative 5, 4. So you don't even have to really plot the point exact. You just have to think about what happens. So call it say for any point, if you were to rotate it from here to here, you know, so they are going to swap once it's 90 degrees. So you know, so it's going to be BA. But what happens? Which one changes? Which one changes? It moving from the positive part of the X, the positive the quadrant with the positive X to the quadrant with the negative X. So you know your new X coordinate is going to change its sign. So we swap it. 4, negative 5. But now it is the X one that is going to change the sign. So it's actually 4, 5. Okay? So guys, don't leave your sketch. You see a sketch, you see drawing just make everything just much more clearer, especially with stuff like geometry and so on. So I always encourage students, always walk with your little sketch them for everything, everywhere, even ratio problem, fraction problem, sketch everything, draw it. It helps to make more sense. All right, so that is rotation, and then finally, we're looking at enlargements. And now enlargement is a special type of transformation because this is the only transformation that is not like the other three. You see, the other three translations are what we call rigid transformations. And a rigid transformation does not change its shape or size. So when you transform it, it still have the same shape, it still have the same size. Just a point on that. Who can tell me, by the way, what's the correct mathematical term for that? What do we call that when two objects have the same shape and same size? What's that word we're looking for? What's that word? Should probably put that in a different color and put it in green or white. So when two objects have the same shape and the same size, what does that mean? What do we call it? It starts with a... No, I'm not telling you what it starts with. Yes. Christina, why you talk about what it starts with? Yes, that's right. Congruent. Good. So, in a rigid transformation, the image and the object are congruent. So you see this one, translation, it's a rigid transformation. A reflection is also rigid. Rotation, rigid. You can't remember them look the same, you know. But with an enlargement, even though it's the same shape, it's not the same size. So an enlargement is a non-rigid transformation. Okay? And that's important because sometimes CXC might ask you to, they might say, state a geometric relationship between the image and the object. So that's one of the words that they're looking for, or one of the properties, to state either if it is congruent or if it is what we call, no, I'm not going to say it. I wonder if you guys know that one as well. Same shape, different size. What do we call that one? What's that word? Christina, if I ever see you put what it starts with in the chat, you see? Same shape, same size. What is that one? You can tell me. What's that word? sounds like. Let me see what you guys thinking. We can write it in the chat. Or if you're not sure, start being not sure. Oh, wrong thing I put here. So same shape, different size. I am the problem. Same shape, different size. Not same shape, same size. Sorry, I wrote that wrong. Same shape, different size. What is that? Not congruent, because congruent is same shape, same size. But it's same shape, different size. Yes, that's right. That's right, Amoy. That is similar. So enlargements are similar. Alright? And that's an important thing that we need to know. Alright? Now, in an enlargement, one of the main things we look for, we have the center of enlargement. And we also look for the scale factor. Am I missing out anything here? Those are the two main things we need. So you might see a question that says, enlarge this object by a scale factor of 3 about the center of enlargement wherever. And you know what? Because of the time, let's just jump into actual problems with enlargement. And we're going to see how we can do them. How those are going to come in. One last thing. You see all of the things that I just wrote down? It's important for us to know how to, when we're describing them, these are the things that you need to talk about. CXC either ask you to, well, just geometric transformations in general, either you do it or you describe it. You understand? So, when you're describing it, for all of these, you're going to have to identify those things in order to get the full marks. And we're gonna look at that. Now, with all that being said, let's jump into a question. Now, I kind of changed it up. I took some questions outside of CXC, but still similar. They'd still ask you for the same thing, because I just want to expose you guys to a lot of different stuff, just to make sure that you get it. Now, this diagram shows two shapes, A and B. And first, it asks you to describe fully the single transformation which maps A onto B. So let me come down here. So now, first of all, just by looking at it, what type of transformation do you think this is? So that's the first question you have to ask yourself. What type of transformation is it? Well, if you look at it, you notice it set the same way, right? But it just moved to another location. So that is a translation, right? Look the same, but it just moved, go somewhere else. So now, when we're dealing with a transformation, if we're describing it, you remember what we said we needed? If we look back, we need the translation vector, right? So we need the translation vector when we're describing a transformation. So now we need to look at this one, right? And we need to identify what the translation vector is. So what is the translation vector? Let me zoom in. What's the translation vector that maps A onto B? If we take one of the points, so let me put this in red. If we take one of the points, or one of the corresponding points from the object to the image, we can figure it out. And you don't even have to do that either. There's a lot of things you can use. You can look at the object itself. You can know. You can use one of the sides, whatever it is. So if we look at it now, this point corresponds to this one down here. So how much spaces did it move? It moved down 1, 2, 3, 4, 5, 6. Okay? So it moved down, let me write it here, down by 6 units. What about its movement in the X or Y direction? Well, it didn't move to the left and it didn't move to the right. So that means we can use 0. So it moved 0, units across. Okay? So let me rewrite this so you see better the translation vector. 6 units down. Now sometimes one thing I notice when students do geometry and working with a graph in general, be careful not to count the points, count the spaces when you're dealing with distance. So don't count it as 1, 2, 3, 4, 5, 6, 7. No. You're counting the space that it's moving. So what's the space? You're moving 1. Oh, there's a different color. You're moving 1, 2, 3, 4, 5, 6. Okay? So that's why we say it's 6 units down. So now, what is our translation vector then? Remember, translation vector is in the form xy. So that means our translation vector, the x is 0. Right? The x is 0. And 6 units down. Because we're going down, it's going to be -6. So that is our translation vector. See? So to describe it, I don't think I have enough space here. Let me zoom. To describe it, we would say that A is mapped onto B by a translation using the vector, using the translation vector 0, -6. Alright? Now, when I'm looking back on this, it don't look so cohesive. I could have worded it better. But the point is, you just want to highlight the main things. One, the object, and which one is the object and which one is the image. What type of transformation it is, and the relevant information for the transformation. Okay? So because of translation, we talk about the translation vector. You understand? So those are the main things that we have to identify. And now, for that one, you get 2 marks. Probably CXC will give you 3 marks, but yeah, it's pretty close. Right? Now, is anybody not sure about how we know why the transformation is a translation by that vector? Anybody have any questions with that one, or are we clear? Do we see it? So good to go. Let me know in the chat, because remember, I'm here to help you. So it's all about you, not me, or not us going fast or anything. I just want to make sure that you guys are with me. If everybody good and you're working with me. See? So talk to me. We good? Alright, Jonathan. It's asking me to repeat. Alright, no problem. So let's just look back on it. Right? So first of all, and that's a good question, Christina. How you know it's a translation? A translation only moves the object, but its orientation stays the same. So that means it's set the same way. It just gone somewhere else. So in this one, you can see say it's set the same way. It's set so. It sets so up there so, and it sets so down here so. So it's set the same way. So that's how we know it's a translation. If it did set another way, for example, let's say the image did look like this, then we know say that's not a translation because it's set different. Everybody with me so far? Or let's say that the image was set like this. Is that a translation? Is that single transformation a translation? What do you think? Is that a translation? Yes, it is not. Because it flip. That one is a flip. It's not the same. So that one would be a reflection. Alright? So a translation, it's set the same way. So just make sure say you look for that. Now, when you're looking at the movement for it, once we deal with translation, we're dealing with the translation vector. So we have to look at how much it moves by. So when you look at it, let me rub out this part just to make sure we see it. So when you look at it now, it moves 1, 2, 3, 4, 5, 6. So that's why I say 6 units down, 0 units across. Therefore, that's why the translation, we describe it as a translation with the vector 0, -6. Okay, alright, so it's all good. Alright. Now, on the grid, we want to draw the line x equals 2. So where would that be? Well, I'm going to go to, I forgot to use red CMA. Remember about this. So I want to draw the line x equals 2. I'm going to go to the x-axis, find 2, and then draw my line there. So this is the line x equals 2. Okay? And you'd get a mark for drawing that line. Now, it says, I remember your x lines are always vertical. It says, on the grid, draw the image of shape A after the following transformations. First, a reflection in the line x equals 2. I want to label the image C. So we are doing shape A. So we're going to reflect it in this line. So now remember, with a reflection, the principle is that they are the same distance away from the mirror line. So we can take each of these points, or at least one of the points, and look at its distance away from the mirror line. So in this case, what you notice, A is 1, 2, 3 units away from the mirror line. Cool? So this, if that point is 3 units away, that means the next point is also going to be 1, 2, 3 units away. Alright? So we're going to have that point right here. Now, you can do it for each of the points, or you can at least just use one of the points to complete the reflection. So since I know it's that one, if I take the rest of them, I realize this is 1 unit. So I can draw back this side here, so realize this side is what? 2 units. So I just draw it back here, so okay, essentially you only need one of the points. I realize this side is half a unit, so I go halfway, and then it go back up by 1 unit, and then I think we can complete it from here, so we just join the rest of it. And now, as it said, oh, that one is definitely, yeah, that line better. And as it said, now we just call our reflection C. Alright? And that would be our reflection in the line x equals 2. Okay? Everybody with me with that one? We see how that reflection, the key idea we used here. Just remember that the points have to be the same distance away. So if like this side is 3, that one is also 3. This one is 4, then that one is also 4, and so on. It must, in other words, it's like you should be able to flip it. Huh? Like if you were to fold the paper, they would match up exactly on each other. Okay. Alright, good. So we're good. Now, the next one says, enlargement, a scale factor of 2 with a center of 0, 0. I want to label the image D. So one of the things when we are, I'll go back in a few. I'll go back in a minute. Let me just do this one and then go back to it, alright? So one of the things when we're doing an enlargement about the origin, we can think about it as we can just multiply the points by whatever that scale factor is. Alright? But that only applies to the origin. Sometimes as students might just think it applies wherever the center is, but only if the center is the origin, then we can multiply each of those ordinates by their scale factor. Because it starts from 0, 0. So if it's just going to be twice or twice the distance away from it. Alright? So it says we want to do it by a scale factor of 2 about the center. So we're going to start here. And now let's take let me rub off this. Let's keep that still. Let's take this point here. This point is 3, 1. So enlarge by a scale factor 3, negative 1, 3. Sorry. Don't tell anybody, say I just did that. It's negative 1, 3. So now by a scale factor of 2, it's going to be negative 2, 6. Which is going to be right here. Okay. And then we can do that again. You can just use 1 point or you can recreate the image. Because a scale factor of 2 means all of the sides are twice as big. But I'm going to do each of the points then. So this point here is minus 2, 3. So now our new point is going to be equal to minus 4, 6. So that's going to be right here. This point is minus 2, 2. So that's going to be minus 4, 4. You get the drift? Let me make sure. Look at this point down here. So, oops. No, let me give you this one. What is that point and where is it going to be now? Where is the image of this point going to be? The one that I circled. Where is that image? Oh, sorry, something dropped. Sorry about that, people. Something dropped off. Yes, it's gonna be minus 2, 2. Alright, good. So it's gonna land right here. So it's gonna be right here. And then you notice this one is basically minus 1.51. So if we double that, that's minus 3, 2 right here. And you notice it goes up there. So we can draw it like that. Alright. So now this is going to be our image. Okay. So that's one way that we can do it. And they said that we're supposed to label this one D, I think. Okay. Oops. So that one is D. All right. So once it's from the origin, you can multiply the point, each of the ordinates by the scale factor. Now, let's look back on just quickly on the reflection, like you're asking, Amar. So when you look at the reflection, the key is to measure the points, measure the distance. Okay, so that's one thing that you can do. You know what you can do too? That's why I kind of wanted to do this without like a physical, but it never really worked out. You see, especially if you have a vertical line on your booklet, you can just fold it at the line, because you just want to make sure that they are the same distance away. So when you look at it now, here each of these are the same distance away, and your resulting image should be a mirror. So it should be a perfect reflection on either side. So I say? So that is what we look for in a reflection. So we just take one of the points, and then because we remember that it's rigid, it's gonna look the same way. Once we have at least one of them, we can recreate the rest of it, which is what I did here. Once I took only one of the points, this one, then I just redrew the rest of it at that point. But the thing is, you can do it point by point, you know. Nothing is wrong with that. You can write it out by each of the points. That's fine too. Okay? All right, everybody. Yeah. Can't believe it's 10 minutes to 8. I can't believe I was an hour already. Means we only have time to do. Ooh, alright, let me see. I'm gonna have to pick and choose a question. I wanna get a good one that kind of covers everything. Let me see, this one or this one. Alright, you know what? I'm gonna do this one, and we're going to try squeeze in that last one with rotation, because I realize that's the one a lot of us have a little problem with. Now, in this question, it says the diagram below shows triangle RST and its image RST prime after a transformation. First, it asks us to write down the coordinates of R and R prime. What would those coordinates be? Write it in the chat for me. What is R and what is R prime? What are they? So I'm looking out now for your answers in the chat. What would those be? Alright. So Christina is saying 2, 4 is R, and yeah, that is correct. Because notice R is 2 units to the right, 4 units up. Good. So R is 2, 4. And yes, I'm seeing, is R is 2, 0 or 0, 2? Remember that X come before Y, okay? It's kind of like an alphabet. So you start with the X1, so we say 2 on the X axis, and then it don't go up or down. So it's 0 on the Y axis. So R prime is actually 2, 0. Alright? Now, describe completely the transformation that maps triangle RST onto RST prime. Before we so now first we have to identify what type of transformation is this. What would you say? What type of transformation is this one? What type of transformation? Is it an enlargement? Is it a reflection? Is it a rotation? Is it a translation? Which one is it? Now look at it, you know. Look how it said. Should help you to decide. So one answer so far. Looking for 2 more to see if they agree or disagree with that. Alright, 2 that. 1 more. Okay, good. So we realize that it's a reflection. And we know that because it flipped. Alright? Now, in a reflection, what do we need? What do we need in the description? We need when we talk about a reflection, we need the mirror line. Okay? So, we have to look and see if there's a mirror line. So remember, at the mirror line, the object and the image are the same distance. So basically all we need to do is just look at the distance between them and cut it in half, because it's going to be the same distance. So from R to R prime, we notice that's how much? 1, 2, 3, 4 units. So the mirror line must be halfway in between that, which would be right here. Let me draw it on the figure. That is not a line. Jesus. Yeah, this one. So that would be our mirror line, because here the points are the same distance away from the line. And you guys realize that that is the line y equals 2. Very good. Because it is cutting the y-axis at the value 2. So how do we describe that? We can say that, let me zoom in here. Now you have to make sure you include that information. Because look at this. You see, if you just write down y equal 2 in the answer, you get out. I know, you don't get a big fat 0. You probably get 1 for writing the mirror line. But you have to describe the transformation completely. So you have to say what is the object and the image, say what the transformation is, and since it's a reflection, identify the mirror line. So that's why now I'm going to say RST is mapped onto RST prime by a reflection in the line y equals 2. Alright? Now, third one, it says RST undergoes an enlargement from a center 0, 4 and with a scale factor of 3. So on our answer sheet, we want to draw the triangle RST double prime, which is the image of RST under the enlargement. Now, let's do that. So first, let's identify the center of enlargement. So center enlargement, it says is, let's say it is again, 0, 4. So 0 on the x-axis, 4 on the y-axis. So 0, 4 would be right here. I hope you guys see my 0, 4. Cool? And now we're enlarging it by a scale factor of 3. Now that means we are going to go, we're going to whatever distance it is, we're going to multiply that distance by 3. Looking at what I have here, I did not get all of the answer sheet, you know. Well, let's see what we can do. So, first, just to give you the idea, because I don't think what I have here is not going to fit on it, but we look at the distance from that center. So, when you take that center, 0, 4, let's start with the point R. R is 2 units to the right. So if you enlarge it by a scale factor of 3, that distance is also going to go up by 3. So instead of being 2 units to the right, now it's going to be 6 units to the right. So it's going to be 1, 2, 3, 4, 5, 6. So that means R double prime is going to go right here. Alright? It's going to be R double prime. Now, next, let's take the point T. Feel like this is not legible. Let me try green. No. Should probably still use the red. Let me go back to the red, because I don't think you guys can see that good. So 1, 2, 3, 4, 5, 6. So this is where R double prime is going to be. And so next let's do T double prime. So look at T. Where is T? T is 1, 2, 3, 4, 5 units to the right and 1 unit away, 1 unit up from that center. So if we're going to multiply that by 3, instead of 5 units to the right, it's going to be what? 5 times 3, 15 units. So we have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's just assume that it's out there. And it's going to be, instead of 1 unit up, no, it's going to be 3 units up. So 1, 2, 3. Alright? So that means T prime is going to be somewhere right. T double prime, sorry. It's going to be somewhere up there. Okay? So now, if I were to actually set the point, it's actually going to be 15, 7. Okay? And then finally, we have S. Right? So now, S, where is S? S is at, let me draw the line. S is at 1, 2, 3 units to the right, and 1, 2, 3 units up. So now where is S double prime going to be? Let me see if you guys are with me so far. Where is S double prime going to be? Tell me what the point S, we know say it's going to come off of the graph because I don't have enough space. But based on what we look at, what is the point S double prime going to be? Let me see what you guys are thinking. I wonder if this was, was this the graph then give them in CXC? I don't know, you know. I'm not sure. How we get T double prime to be 15, 7? Alright, let's go back to it. Hold on 1 minute. Let us go back to that. So now look at it, right? I wish, you know, should I get it? Sure. Look at where T is. So T, let me write it out. So T is 5 units to the right and 1 unit up from the center. So from 0, 4. And follow me with that? Because when we count it from the center, it's 5 units to the right and 1 unit up. See? That is that. So no, that is the thing I wanted to address. Because it's not coming from the center, you wouldn't just multiply the points by 3. It have to be coming from the center for you to do that. So once from the origin, the center of enlargement has to be from the origin for you to just multiply the points. And that's a common mistake students make. So it's not that you just multiply it by 3, but you multiply the distance away from the center by that scale factor. So because it is 5 units to the right and 1 unit up, by a scale factor of 3, you're going to multiply the distance by 3. So that means T double, let me put it here, T double prime is going to be 3 times 5 units or 15 units to the right. Right? So now it's going to be 15 units to the right. Because we're multiplying the distance by the scale factor, not the points themselves. It only happens with the points if you're at the center, if the center enlargement is at the origin. Give me a thumbs up in the chat if you understand what I'm saying, because this is a common mistake and I don't want you guys to go and make it. So give me a thumbs up or give me a thumbs down if you're not, if you say, I don't know about that. So let me know. Should probably write that here too. So that is the idea. That's the concept. We multiply the distance from the center. And don't feel no way, because so you learn. So I'm happy that we fixed that. We at least fixed that. Because a few people thinking the same thing as well. So that's good that we get that. So now instead of 5 units away, it's 15 units away. And instead of 1 unit, instead of 1 unit up, now it's going to be 3 units up, because we multiply that distance by 3. Alright? Alright, I see some people still not seeing what we're saying. So let me touch on it one more time, just as an example. Let me come over here. So let's say that I had a graph. Right? Drop me a graph. And let's say, so we have X and then we have Y. And let's say that I had some semblance of a square, and I was enlarging it about the point, about this point right here. Let's say that is 1, 1. See? Now just think about the idea of distance. When you say something far or something is further away, if you say something is twice the distance away from a point, it means that it must be in that direction you're talking. So if I were to say that, let's say that I made the square twice as large, right? Then we know twice as large means that the sides are going to be 2 times as large, 2 times, all of those would be twice as large. We know that. But the center of enlargement tells us where it is going to be. Okay? So, because it tells us where it is going to be, if I had the center enlargement here, it would be different than if I had the center of enlargement above it, or to the left, or to the right. Okay? The center enlargement determines where it is. You know what I'm gonna do? Cause you best see this with a Let me see. Give me 1 minute, guys. Let me see if I can get something for you to see. Just for you to understand the idea. Cause me saying it, you're not going to really get what I'm saying. Let me get it. Sign in with my Googles. Yeah, I have something like that just right on my math camp that I can bring up right now. Same way. So just give me like 2 minutes, people. For those who still not getting what I'm saying. Where is it again? Oh, should I probably had it handy now. What is this? Transformation. Enlargement. And okay. Let me get this back on. Copy. Metal. Plugin. Hey Akila, we're doing transformations. Looking at some transformations. So there was something that everybody was kind of not so clear on, so I'm just getting this little thing that can help, a little applet that can help it make more sense. Alright, I'm gonna add another window. Where is it? Okay. You guys seeing what's going on here? This is my website, by the way, my math camp. So we have like tons of stuff on it that you can see. Apps like this that can kind of help you, make sense of math and stuff like that. Okay. Let me know if you see my screen. Oh, but you can't see my mouse. Probably not. Everybody see my screen? Okay, great. All right. So now, when we say the center of enlargement, this is a little applet that I have that it shows you how the thing enlarges over time. So you have a scale factor of 1, it match it. Let's say we have a scale factor of 2. See? Now what do you notice? Look at this point here. This is my center of enlargement. So if you notice for L, how far away is it? You guys not seeing my mouse, but for L, notice that it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So now we don't have no origin, and we don't have any points. We don't have any values for the points like 3, 1, or 2, whatever. But look at the idea of it. Because it is 1, 2, 3, 4, 5, 6, 7 units away from the center, that is the point L. If it is enlarged by a scale factor of 2, now it is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units away. Okay? So because it is now enlarged by a scale factor of 2, the distance is it's twice as far away. Every point is twice as far away from the center of enlargement. If I bring the center of enlargement closer to the figure, notice that now, before it was 1, 2, 3, now it is 1, 2, 3, 4, 5, 6. And that goes for all of the points. So it is the distance away from the center is what we use to enlarge a figure. If it's a scale factor of 10, we just make it 10, the distance be 10 times as much. And so on and so on. That making a little more sense, everybody? Does that help? In terms of make sure you measure it from the center of wherever the center enlargement is and not just multiplying the points. What say you? Good. Oops. Okay. All right. Great. So remember, so we just make sure that we. Wait, this. Oh, yeah. Make sure that we focus on that part. And so let me get rid of that now. So now let's go back to our question. Then let's go back to our question. That is why here we said the distance is now 3 times as far. So it's going to be 50 units to the right and 3 units up. Because we multiply the 2 distance then by 3. So that means that is how we get 15, 7. Because it was 5 before. Now it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 units to the right. And T, instead of being 1, it's now 1, 2, 3 units up. It's really sorry that I didn't have the graph paper for you to see it exactly, but I hope you guys get the idea that I'm saying. So that is why it would end up at 15.7. Alright? Now let's look at the last point, S. So this is the big test now. I could look at S to make sure say everybody gets it. I'm looking for everybody now in the chat. S, where is S? S is the point, or not the point rather, let me say. S is how far away from the center? We said that it was 1, 2, 3 units to the right and 1, 2, 3 units up. So it's 3 units to the right of our center, which is 0, 4. And it's 3 units up from the center as well. So if you enlarge it by a scale factor of 3, 1, how far away is it going to be now? How far away is it going to be now? That's the first thing I want you to tell me. S prime is going to be what? Let me see if you see what I'm saying. I don't like when you say 9, you know, because that almost sound like a point. But remember, it's not a point. I would rather you say you're 9 units to the right, right? So you have the idea, but just so I make sure you get it right. It's 9 units to the right. Okay. And what else? It's going to be 9 units up from our center 0, 4. Right at the bottom. You understand what I'm saying? So I don't want to see you say 9 because that almost sounds like it's the point you're saying. So since it's 9 units right and 9 units up, where is it going to be now? What is S going to be? So remember, S is already, we know say S is what? S is 3, 7. So when you move S 9 units right and 9 units up, where is S going to be now? So where is S going to be now? So let me see what you guys, let me see if you get it. I'll make sure I say I get it, you know. Where's S gonna be now? Yeah. Yes, Christina, it's not gonna be at the graph. That's right. But try put that in CXC though. See what I'm telling you. I soon answer your beauty key, but let me make sure you guys have the answer first. So where is S going to be? But take your time, think about it. Where is S going to be? No, remember, no, it's 9 units to the right and 9 units up from wherever it was originally. So look at it this way. You're taking the point S, which is 3, 7. First, you're going to move it 9 units to the right. So 3 is like you're going to add on 9 to it. I don't know if you guys following me. So it's like you're going to add on 9 to 3, and you're going to add on 9 to 7. Okay? So now, when you do that, S double prime is going to be 12, and 7 plus 9, 16. Alright? Again, it's so unfortunate we don't have the graph. I wish I had a graph. I wish I had it in paper, because like you could draw it too, you could draw the lines them to know. But that's how it is. So remember why we said that the scale factor is 3. So one person is saying, why are we moving 9 units? Remember the scale factor is 3. So we're going to be 3 times away from the center of enlargement than the original. So because the center enlargement is 0, 4, since S was 3 units to the right and 3 units up, away from it, now it's going to be 9 units to the right and 9 units up, away from the center. Guess what, guys? You know what? Let's just fix that a little bit. Let's just fix that a little bit. It's not 3 plus the 7, you know. It's from 0, 4. So what we should actually have here is, sorry about that, it should be 0 plus 9 and 4 plus 9, because it's from the center you're dealing with. So it would actually be 9, 13. My bad. Thought I wrote down the center enlargement. Right? So that would be our distance. That's the distance that we're dealing with. See? Because that would be the enlargement. Now I'm seeing in the chat, so is the center of enlargement always given? No, sometimes they give you the enlargement and they ask you to describe the transformation. But that now, to do that, you see these lines that I drew? And I had another question like that, you know, but unfortunately the time run out of us. But basically you can recreate the lines between the enlarged figure and the object to get the center of enlargement. So for example, let's say that S was, so S is at 9, 13. So call it S is probably somewhere up right here, so S double prime, that is. Now if I were to draw the triangle, so from R, S, R, S and T. Sometimes this thing kind of like jump off, you know. Call it right here, so. And right here, like this. Then to do it, to draw it, to get the center enlargement, you can just connect back the lines. So in other words, you can draw a line from here to here, and here to here, and here to here. And when you do that, when you connect them back, then you will realize that you're going to find all of them going to meet at the center. Alright? Likewise, to find a scale factor, notice that question. If you want to find a scale factor, you can look at the units, the size of the sides as well. So you can probably tell based on how big the sides are. So you have to look at each side and say, how much bigger is it? Is it twice as big or 3 times as big? But realize this one was one that we wasn't so 100 with. So we're going to have to, that one now, we want to make sure so we get that. Because we know transformations coming in the exam. If they ask you to find the scale factor of so and so, yeah, that's what I mean. So you look at the lengths of the sides and compare them. So guys, you can believe it, it's almost 8:30. Usually we try to spend an hour here, but here we are about an hour and a half. So I don't want us to go too much, you guys to get too tired, plus a Friday. So probably you guys want to relax and get yourself ready to do some prep for the weekend and stuff like that. So let me ask you a question. Because we don't touch rotation and enlargement yet. I can't guarantee if we will be able to go through that based on my time. But would you want us to do finish up this session? Would you want us to for both reflection and rotation and enlargement? Because this question nice, it even have some more parts in there. Trinidad, it's 9:25. Yeah, that's crazy. Here I'm in Jamaica. It's 8:25. So we're an hour behind you. It's pretty late. But it's good to see you on. Same way. So if you want us to, I think I can't promise anything, but I think we can probably have some time might have some time in next week, but we know next week is exam week still. But yeah, you have more here in terms of more ideas for enlargement, more CXC questions. So you know what you guys can do too? Here's a question, the other question that we're gonna go through. You can probably, well, you don't have to take a screenshot, you can just come back and see. So here's the question. Can try that one on your own sometime. And then we'll see you. Okay, I'm seeing the 8 votes so far. Everybody wants us to continue. Alright, so we'll finish up. Alright then. So probably next week, sometime next week, probably Monday evening. I don't think I'll be available this weekend. But probably Monday evening we might touch it. No promises still. I'm gonna try and see how my time works out. Alright. Paper 3 Math CXC on the broad topics. You know that I have a video on that? Let me put it in the chat. Like some of the stuff you expect, some of the stuff you should expect, and some of the stuff that you can do. Where is it again? Paper 2, paper 3. So CXC paper 3. What to expect? So I'll put that link in the chat here so that you guys can have access to that. Alright, so you can watch that video. We'll see, hopefully. I don't think I'm not sure if I'm gonna have the time, to do it. But as I said, we'll see. So you guys can look out in the community. I'll keep you guys updated there. And yeah, Christina, we have 1,000 followers now. So that is good too. So thanks a lot, guys. The fact that there are 1,000 here, I hope that these sessions are helping you. I hope what I have on this channel helps you as well. I hope it helps you to get prepared, because remember, it's about you. I make sure you say you pass. So you can look through all of the other ones that we have, the other workshops that we had to revise some of the broad topics. You can check out the videos on the channel, the other ones that can help you to get prepared, how to solve a problem. That's an important one to think about going into the exam. How to do other problems like paper 1 and stuff like that. What to expect on paper 2, what to expect on paper 1. That's the next thing. And then finally, just practice. Just make sure that you practice. Again, you can access the playlist. Let me just send you the link to the playlist. Let me put it in here. So you can go to that link, or you can use this link for all of the free workshops that we did. And I really wish you guys the best. I really wish you guys the best. I hope you guys pass not just maths, but every subject that you have to do. More success, more get them so you can do what you want to do with your life. And for those who sit in it again, don't worry about it. Just put your head to it and you can do it. Don't fret. You might have a little exam anxiety. So just make sure you prepare yourself. Just make sure you keep calm and control what you can. Don't worry about the exam going into it. Because if you worry about it, that can happen. The exam is coming June 1st, whether you like it or not, it is coming. So you have to just do what you can control, which is how to tackle these type of questions. Oh, Christina, Tuesday evening would be out for me because I have a class on Tuesday evening. So I won't be able for Tuesday evening. But we're going to miss you. But just keep your English exam. A joke, don't do that. You can follow up with anything that you may miss. I'm going to leave it recorded. Kiki say, any advice on how much multiple choice to do? Like how much papers in preparation? You can do as much as you can, I would say. Don't limit yourself and say, you're going to 3 or 2 or whatever. Just do as much as you can. And the thing is, those questions repeat too, Some of them repeat, so it's good for you to look at them. Because they might come back the same way. Even if they don't repeat, they might change a little thing in it. Right. So per night closer to the exam, I would say you can try to do a paper every night. So the paper is an hour and a half, time yourself. And then that's the thing too with maths, CXC maths, there are abundant resources for it. So you can do the paper one, get the past paper, and then mark yourself afterwards. And I'm sure there are tons of other guys online, women and guys and girls, and people online who can help you. They go through the paper one, they go through paper two in its entirety as well. So you can check them out too. I know that they have some good stuff. Alright, everybody, so have a great night. I will see you guys in the community. All the best.